Hello, hello, hello. Is everybody hearing? Is everybody hearing me? Great, 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 great. All right. So I'm trusting everybody as what they want to cover today. All you have to do is just type that request in the chat, and I'll be more than happy to explain, demonstrate, and show you what's up with that. So I need to find a way to manage the chat while I'm showing you what's going on. But now that I know that you're all hearing me, let's see how we can do this. Mhm. Disable to dock. Trying to figure out the streaming thing. Hmm. So we're seeing everything in there. So we're seeing that there are mechanical persons in the chat. We're seeing that there's building persons in the chat. No worries, we're going to be helping everyone. Well, let's see what will happen. All right, because I don't want to keep you guys up too late. I think it's a morning exam, so you want to ensure that you're fully rested for the exam, whether you're doing traditional method or using computer based. So we're seeing assembly drawing. All right, we're seeing 22 CXC building drawing paper. Everything, come on. All right, so let's get into the thing. I hope everybody is able to see my screen. Everybody is seeing my AutoCAD screen here. This is where I'll be doing all my typing, all my notes, as well as all my demonstration. Now, where I am, it is currently 11 o'clock. Depending on where you are in the Caribbean, it might be 10 o'clock or somewhere in between. All right, so let's see how much we can get done. All right, so let me skip to the top and then I'll work my way down. I'm not sure, Zach, I'm not sure what you're talking about. 4K 60 FPS. Do I need to change some setting on my streaming thing here? Is everything lagging? Is there a lag? Is everything not visible? I'm still trying to set things up. Most of section 2, please. Just two mechanical building people would find their way. Oh, don't say that. Oh, okay, great, great. All right, so let me just cut off the noise in my background and let's get things going. And wait one moment. Let me see. How can I do this? I think they said that the chat thing here is dockable. Participants, timestamp, send feedback, participants. Right, trying to set this up so I can see the comments as they're coming in live, unless I'm going to be viewing them on my phone. Either way, I must answer all questions. So let me see if I can pull it up on my phone so I can view the comments. All right, so just give me a sec. I'm going to be pulling that up and then then we'll get things going. Let me turn on my Wi-Fi. Sorry about the late start. I got kidnapped for a little while and I just got in. So let me see now. Give me a sec. I'm trying to pull up the comments on my phone so I'm better able to assist you guys. I'm trusting that everybody has pretty much explored the videos that are on the channel. So while I'm pulling that up, just want to say, for mechanical persons, there is only one thing that they're going to ask you on the exam. All right, only one thing that they can ask you to do. Well, and it's going to be an assembly drawing. Now, this assembly drawing, I always recommend using something that I like to call the puzzle method. I don't know if I'm the one who came up with that or it was somebody else, but it's just something that I've noticed and I've practiced, and I've noticed that many persons are actually doing it now, where we actually draw the given parts that they have given to us and we simply overlay them or put them on top of each other um, to get what we want. So for example, if they say side plan, not side plan, but um, elevation as well as plan view, it means that you're only concerning yourself with the plans portions of the drawing. So all you're doing is just reproducing what they give to you. Alright? That's the first thing that you should do as a mechanical student. Just draw what they give to you and then you figure out how they're going to be assembled afterwards. I'm still trying to find, how do I find this on my phone? You know what? I'm going to be back and forth. Let's not waste any time. Foundation plan. Mechanical drawing. Alright, so let me head over to here where I can pull a mechanical question quick and fast. Alright, so you can see past paper, technical drawing, trying to pull these questions up. I will never understand how people, how persons stream, but I guess they have a team. Alright, let's see. Assembly drawing practice number 8. Let's pull this up and let's see. Now, over the past few years for mechanical drawing, it they have pretty much made things very simple for you guys. I don't see any problems there. Really don't see any problems in terms of like what they're giving you and what you're required to do. Where persons might fall down though is the sketch and design portion. As you know, tomorrow the exam will be about 2 hours and something minutes. Is it 2 hours 40 minutes? Whatever. Alright, so you know it's probably more than enough time. So if you're a fast person, you would be able to complete the drawing, and all you have to do once you have completed is to basically go through now and spend a bit more time to make your work a bit more neater. Alright, so here we have a typical part sheet that will be given to you, or what you'll find. Now here I have mine in AutoCAD, but tomorrow you'll have the paper in front of you. It's a little ready, so let me just try to do something here, here, here. Alright. All right, so typically they'll ask you to do like a end view and a sectional, or they might ask you to do a plan view and a sectional. All right, assembly. All right, now typically you'll find it things laid out like how it is here. All right, where you will have like an end view. In this case, this is an end view and this is a sectional view. Here is somewhat of a plan view of the body itself. Now this plan view is actually showing you what it looks like up here. I hope you can all see my cursor. Alright, so that's what that is showing. All the parts will be numbered and labeled. They'll also tell you where the parts should go, alright, to make things a bit easier for you. So it gets no easier than being a mechanical person doing TD, alright, because you're not trying to figure out anything. All you're doing is reproducing what they give to you and assembling it according to how they say it should go or where it should go. So for example, you'll find them telling you exactly. So they might say, draw a full size either in first angle or third angle orthographic projection. Um, First and third angle orthographic projection is just a fancy word for how the drawing is organized. For those of you who might not know. All right, I'll get the building. I'll get the building. What I'm saying that it's going to tell you first angle or third angle, which one you should be doing. As I said before, first and third angle is just a fancy word for describing how you organize the drawing. So for example, for first angle, all it means that the plan is going to be at the bottom, and then you're going to have the direct elevation or the front view at the top, and then you'll have the end view to the side of the elevation. If you're mechanical, you know what I'm talking about. Nothing major there. As I said before, it gets no easier than being a mechanical student, because uh, the worst case scenario is that you draw all of this and you're unable to assemble it, or you're not or you have not assembled it perfectly. You'll still get your marks. Building person, things are a bit more complicated for you guys, where there is so many variations of things that they could give you, while the mechanical person will know that they're doing a plan view and a sectional view. Building persons, you really can't really know what they're going to give to you. All right, now they could give you a floor plan to complete, right? They might give you a elevation to complete. And when I say give you an elevation, what I'm saying, they're going to give you a floor plan and you have to create an elevation from that floor plan. Or they might give you that floor plan and say do a sectional drawing from that floor plan. Or they might give you a floor plan and say do a roof plan from it. They might give you a floor plan and say do a foundation plan for it from it. All right, so there's so many variations that they could do. All right, as well as site plan. Now over the past few years, here are some of the things that have come on the exam, and they typically try to touch on all the things. So I believe last year it was a elevation. The year before was a sectional. No, the year before was a floor plan. The year before that was a sectional. All right. So far we have ruled out. I doubt they will bring floor plan back again this year. I doubt they will do elevation since it came last year. Though they will do sectional because it came the year before. So the other options are they might give you a side plan to do, or they might give you a roof plan to do. All right. I'm not saying that that is what is coming on the exam, but what I'm saying is that the possibility or the probability of that happening is very high. The possibility of you getting a roof plan or a side plan is very high. All right. Also, possibly a foundation plan, but foundation plans are so easy. I doubt they'll actually bring that for you. All right. Now, let's see what can happen here from these comments. So roof, I'm not saying roof, I'm saying that it's a possibility. All it is a possibility. All right, all it is a possibility. Not necessarily draw a house. What they'll do, they'll give you a simple line drawing, and then you'll have to complete. So here's what I'm going to be doing. I'm going to be doing a quick, For mechanical drawing, question 2, that's a sectional drawing. What I'm expecting from them this year for mechanical drawing, because last year they brought conventions and such. Um, they could, this is what I'm expecting for the sketch and design portion and for a mechanical person. Is side of two things going to come. They're going to give you an orthographic drawing and tell you to do a isometric drawing from it, or they're going to give you an orthographic drawing and say produce an oblique drawing from it. It's one of the two. Since they already brought, they already did the conventions last year, the year before they did types of sections, so on. So this is what is most likely to come this year. All right, and it means that you need to know how to produce isometric drawing and oblique drawing. Alright? If they do bring conventions, I'm guessing you would have gone through the notes and all that stuff that your teacher would have given to you. So let's see. Yeah, oblique. Oblique or isometric. That's what I'm thinking. It is the most logical explanation in relation to what might come tomorrow for sketch and design for a mechanical person. For building persons, yeah, there's so many things that they could give you. You just have to know everything for building person. Typically, they might ask you to do a sectional view of something, always. Well, there might be a ridge detail, eave detail, foundation, footing detail. Last year they asked for, or they have person do, I think it was load bearing and non-load bearing walls, and they had like windows. So I always encourage persons or building students to know the different types of windows, all right, the different types of doors, all right, also different types of roof. And when I say the different types of windows and the doors, is not just knowing how it look, but know how it works and what a sectional view of that door or the window would look like. Building persons are never cook. Alright, never cook. The only way you're cook is if you have not been doing anything since fourth form. Now, as long as you did your SBA, you should be fine, because everything that is given on your SBA is what they typically test you on. Alright, and you're never cooked, alright, because you're simply drawing. Once you know how to use the software, or you know how to draw if you're doing traditional method, you're pretty good. So let's get into things where I'm going to be demonstrating something. So either way, you should be ready. Well, this is just a revision session here, but let's see. Let's make my way over to AutoCAD. Let's just make my way to AutoCAD. I hope everybody can see this. Again, I'm going to be going back and forth to see what the comments are saying, just to ensure that I don't miss anybody, because the chat is going crazy now. Chat is going crazy. All right, so what I'm going to do, I'm just going to do a quick layout on my screen for you guys so you can see, and I'm going to be doing a quick sectional view of it, a quick foundation plan of it, and quick just about everything, just to give you an insight on how you tackle these things. All right, how you'll tackle these things. So let me go here, ACONC. All right, now I know somebody, I saw the comment, I think yesterday or this morning, but I was so busy, when they were asking me, how do I draw two lines all at the same time? Because some of you, that is if you're not using AutoCAD architecture, you'll probably draw a wall by simply drawing a line, and then you would offset it by a certain amount, say 150 or 100 or whatever it may be. This is what you'll do, all right, which takes up a lot of time. All right, but what if you could draw two lines all at once? All right, two lines all at once. All right, now there's a way to do this, and there's a tool that is called the multi-line tool. All right, now depending on the version AutoCAD that you're using, things might vary. All right, things might vary. And yes, I'm touching on side plan as well. I'm going to be touching on side plan. I'm going to be touching on how you draw the boundaries as well. So I'm going to be touching on how you draw lines at specific angles and all that stuff. All right. Yes. All right. So let's get into things. All right. So many things to do. This needed a few sessions. All right. So let's go. So to draw two lines simultaneously or to draw two parallel lines at the same time, the tools that you use or the command that you use is multi-line. So whether you want to pull it, find it somewhere up here, but I always encourage persons to know the shortcuts. They are your best friend. The shortcuts for AutoCAD are quick access. So even if in the exam, all of this up here, all of this that is up here disappears, you'll still be able to do your work. Why? Because you know your commands. Now, a quick rule of thumb when it comes on to command is that the command for all functions in AutoCAD is always the first letter or the first two letters. So if it says line, first letter for line is L. You're able to draw a line. If it's a circle, then you know it's C, right? It's always the first letter or the first two letters of the function. So for example, if you want to move something, it's simply M and press enter, and you'll be able to move whatever you need to move. All the commands, that's the principle. Not even if you don't know where to find it, this is how you're going to access it. So if you want to erase something, simply type E and press enter, because why? It is always the first letter or the first two letters. Alright, now in this case where we're just trying to draw two parallel lines together, and we're using the multi-line tool. Now multi-line is two words, so it means that it's the first letter. So it's going to be M and L. M for multi, L for line, multi-line. Once you activate your multi-line tool, you'll be greeted by a window down at the bottom here. It says justification, scale, and style. The one that you should be focusing on is justification and scale. Alright? Now justification is just telling you or saying where do you want your cursor to be in relation to the two lines. Now in AutoCAD or in drawing overall, everything is located somewhere in relation to something else. When I say, what does this mean? If there's 5 persons in a room, right? And they're spread out all over the place. Alright? Say someone is at the door, somebody's at the window. Now, the distance from the window to the door is a specific measurement. But the distance from the window to somewhere else in the room is also a specific measurement. Alright? Now, you can use those measurements to determine where something would be. Alright? Because everything is located somewhere in relation to something else. You are 5 feet away from the door and 6 feet away from the window. Alright? Likewise, you might also be 5 feet away from the door, 6 feet away from the window, but there is somebody behind you and you are 1 feet away from him. Now, justification is the same treatment. Now, you'll find that there's 3 justification. You'll have top, 0, and bottom. All this means is that your cursor, and I'm going to select top in this instance, you'll realize that if you select top, it means that your cursor will be at the top of the two line, or to the right of the two line if you want to think about it like that. Alright, that is what top means. If it is 0, if justification is 0, it means that, and you select 0, it means that your cursor is going to be smack in the middle of the two lines that you're drawing. And if you choose bottom, your cursor is going to be snapping to the bottom portion here. And this comes in very important. It is a very important thing, especially when you're trying to do or replicate a floor plan and you want the measurements to be accurate and you don't want any issues. Alright, so for example here, right, I'm going to be doing a quick house, if you want to call it that, and as you can see, I'm easily drawing my walls and all that stuff without any issues, without any problems. I'm simply just drawing the walls, but you'll notice the edges of there, the edges of the building pretty much changing and all that stuff. Alright, so you decide how you want to do your thing. Alright, so I have a little room there and I have one there. Alright, now you can fillet these as well, or fillet, whatever you want to call them. You know the functions are similar. You can't use this fillet here to fillet the corners, because this here is like a total entity. This is like a polyline. All right. So if you're going to be using this fillet tool here to fillet the corners, you'll have to explode these lines. So you simply click on them and then explode it. Again, shortcut for explode is X. All right. And you'll press enter and then you'll be able to fillet the corners. The only other option to fillet these type of stuff is basically using multi-line edit tool. Alright, but save yourself the trouble of doing all that and simply just explode and then do what you have to do. Alright, now something to note, and because we're here now and this is my simple floor plan. This is my simple floor plan. Alright, I'm going to do something a bit ridiculous now. So I'm going to go EX, enter, enter, and now grab everything. That should sort things out. Guess not. Because this is where we're starting. All your drawings are starting at this point here. So what I'm going to be doing is that I'm going to be explaining the foundation plan. I'm going to be explaining the roof plan. And I'm going to be doing all of that from this little layout that I have here. Alright. So let me just clean things out. Alright, so here I have my little layout. Now, say for example, you have this here, right? Now I want you to think about this like you have the paper in front of you. You're given the floor plan and they want you to do a foundation plan or do a roof plan. Alright? Maybe I should add something to the front here to make things a bit interesting. So when I'm doing the roof plan, things are a bit better. Alright, let me just do that then. Now, my trimming function is a bit different because I'm using AutoCAD 2020. But if you're using the more modern version, you'll realize that when you activate the trim command, it will actually allow you to trim away portion by portion. So you have to be mindful of that. And please don't worry about the exam. Please don't worry about the exam. It's not that serious. It's never that serious. Alright? Just have fun in the exam. Do your work and just draw. Once you get in the exam, just draw. Don't worry about anything. Just draw. Alright? Especially the mechanical persons, just draw. Building person, don't just draw. Read the instruction or your goose will be cooked. Alright? It's very important that you read the instruction, building persons, because that is how you're going to know what to do. Mechanical person can just take up the part sheet and just start drawing. Alright? But you can, because you don't know. Are you doing an elevation? Are you doing a foundation? Are you doing a roof? So here I have my typical floor plan layout, if you want to call it that. Alright, now here is how you typically do a roof plan. Alright, let me copy this to the side here. This is how you typically do a roof plan. And this is my technique that I recommend. So say you have all these lines here, right? And there might be several lines that you actually drew to get to this level here. What I recommend that you do is simply join all the lines together. What this will do, it will turn all the lines into one complete polyline. Alright, now once it's a polyline, it means that now you can easily offset the line that is going to be the overhang of the building, or the part of the roof that is going to hang over the building, if you want to call it that. I'm sure you have probably seen many houses with their roofs, and the roof does not stop against the wall. Alright, our water is going to be running down the wall. It extends beyond the wall. Alright, now the dimension for this will vary in the exam if it is given, or you need to produce anything that relates to how far the roof extends beyond the wall. They'll tell you whether it's 450 millimeters, whether it's 600 millimeters, whether it's 300 millimeters. Even if they tell you it in meters, you work with whatever they give to you. In this case, I'm going to be offsetting the outer line by, I don't even know what to do, 450. Alright, just an example here. Here we go. That's not going to work out for me. Offset. Let's try 20 because this is just a sketch here. Alright. So I'll work with 50. just to be sure. 50. So I'll work with 50. Alright, so here I have the general roof outline. All of this on the inside, no. All of that there. Let me just use this. Alright, all of that there is the wall beneath. Now, how do you draw a roof plan? Alright, now a typical roof plan, depending on the type of roof, things might vary. If it's a hip roof, then it's going to be more complicated. If it's a shed roof, is going to be a bit easier. If it's a gable roof, it's going to be easier. Now, gable roof is basically just a triangle. A gable roof will look like a triangle when you're looking at it from the front, just like this. That's all it will look like. Alright, that would be a gable roof. Alright, now what you'll see from a plan view perspective, you looking down at it, you'll see the peak and the two sides. That's all you see. So in a case like this, what you'll see is one line running down the middle like this. Alright, that's what you'll see for a gable roof. Alright, one line, and then you'll have the rafters coming off the side like this. A bunch of lines going across. That's all that would be. Nothing much to that. However, if it's a hip roof, then it's going to require a bit more work. What you'll have to do, you'll have to draw lines, and I typically tell a person to draw lines at 45 degrees. So for example, everywhere there is a corner on the building, you're going to be drawing a 40-degree line towards the center of the building. What am I talking about here? So for example here, and you can use dynamic tracking or you can manually enter the angle. If you're going to be using dynamic tracking and using polar tracking as well, ensure that this is on. Ensure that the 45-degree angle 1 is selected. Currently it's at 30, so ensure that you select 45, click in the corner, and then let AutoCAD do the rest. Alright, you'll see a green line pop up. If you don't see that green line, it means that your line is not at a 45-degree angle. Alright, your green line is the line you need to see. Alright, I'm on the right path. Now at this point you can enter measurement, or you can simply just extend your cursor and click. Now please ensure that whenever you're drawing line, extending line, or moving them around, ensure that the line or your cursor is nowhere near things that it can snap to. Because if you click at any point, it's going to snap to something else. So say for example, I'm trying, and this is just a recommendation to ensure that you're not wasting any time. So say for example, I'm trying to draw my line here. You realize that it's trying to snap to a bunch of other stuff here. So if it's a case where an area is extremely crowded and you don't want it to snap to the wrong thing, move your cursor to an open spot. Move your cursor to an open spot where you know it's not trying to snap to anything. Alright, that is my recommendation. Alright, now also whenever you're dealing with symmetrical objects, and you'll see me do this a lot in my videos, as long as the objects are symmetrical, and when I say symmetrical, I mean that you can pretty much divide it into two equal halves. So for example, this here, you can divide it into two equal halves. So anything that is happening on one side is going to be a similar thing on the other side. So it means that I only need to do half the work. So it means that I only need to draw half over here, and then I can simply, whatever technique you want to use, I use mirror it to the other side. Now, back to where we were. Remember, you're drawing lines at a 45-degree angle from everywhere there is a corner. For example, here is a corner. Here is a corner. Here is a corner. Here, here, here. 45-degree angle line. Alright? So, typically, what I will do once I draw a 45-degree angle line, I'll simply just copy it to wherever I needed to put it. For example, here, there, and everywhere. Once I've done so, I can always again mirror to the other side. And once I mirror to the other side, ensure that your base point for your mirror line is always the center of wherever you're trying to place your lines. So currently you're seeing a bunch of mess here, but there is sanity to this madness here. So for example, we fillet or fillet here and here. Alright. Now we also fillet or fillet here and here. Now you will realize that there is this line here, but realize that this is not a corner. Remember, lines must be coming from a corner. All these lines on the roof plan must be coming from a corner, so we put it right here. So it means that this here will fillet to here. Now, something to also note as well, anywhere you have two triangles, whether they're pointing to each other or pointing away from each other, there is always a straight line connecting them. So for example, we have this apex of this triangle here. So, and we have this apex of this triangle here. Alright, so that's what that would look like. And over time, you'll develop a better understanding and you'll be able to visualize this without having to think about these specialized rules. Again, whatever is happening down here is happening on the top. So all I'll do is something like that. Now again, apex, apex, we connect them with a single line. And that's it. The only thing that would be needed for you to do now is to add the rafters and label them if you get this in the exam. Now, foundation plans are a bit different. And let me check on my comments. Do a section and elevation. Do section and elevation. I'm going to touch on it. As soon as I've touched on the foundation plan, I'm going to touch on that. Please, sir, section elevation. Yes, I'm going on that next. I'm going to go on that next. All right. Don't worry. I'm going to go through all the comments, so I can see how much I can help you guys. So that's the roof plan, and we all know you just draw the lines for the rafters, a bunch of them, and whatever spacing they're at. So for example, if it's 600 millimeters on center or whatever they tell you in the exam, you work with that. You copy, offset. The option is yours. If the option is yours in relation to that. So if you want to copy lines like down like this, the option is yours. For your foundation plan now, things could be a bit different, or it's even easier. And it's the reason why I say I doubt foundation plan will be on the thing. Alright? So all you'll simply do, again, you join everything together. Join. I typed the wrong thing, and simply offset the outer line and the inner lines to show the width of the foundation. Now I explained this in detail, but in other, you probably understand this already from what your teacher would have taught you. Alright, so in this case, you offset outwards here. In this case, you'll have to offset inwards to show that, inwards to show that, again here as well. And then remember, the line that is actually representing the foundation pad itself should be in broken line or in detail line. Why? It's because it's an hidden feature. Now, why is it an hidden feature? Remember, the foundation is underneath the ground. You would not be able to see it. So if it's underneath the ground, it means that you can't see it. And how do you represent things when you can't see them? You put them in detail. Mechanical person would know exactly what I'm talking about. Building person, you should as well. Alright, so there you go. Now, when it comes on to, and let me double check again with those comments. I'm new to this. Yes, sir. I think septic tank is. Septic tank. Interesting. Alright, cool. So I'm going to touch on a simple elevation now. Elevations of what we have here. And then after I'll do a section and then I'll do side plan. Alright. Now this is just to reinforce what you should have already known. I'm guessing you have been practicing over the past, well, for the holiday break, and you going on study leave and all that stuff. For example, think about a door being here, and I'm going to say, alright, well, I guess I don't need to add those. Now, typically you'll be given your floor plan, right? You would not have it like this. So maybe when you were doing your exam, your SBA, you were projecting lines down like this. You were projecting lines down like this. Now, for CXC, you would not be able to do this. As a matter of fact, you would be wasting your time if you did something like this. Meaning that you drew the floor plan and say you're going to draw the elevation from it. No, you're wasting your time. Why? Because they're not going to be, or not going to be giving you any grades for um, drawing the floor plan. I asked you to do an elevation, not a floor plan. So why would you draw the floor plan? You're wasting time there. So you would not be doing things like this. All right. So when we are marking your exam, May, June, July. In July, when we're marking your exam in July, if we see this, I mean, it's up to our judgment, but we did not ask you to do this. All right. What would you, are you being asked to do? All right. All you're going to be doing is picking up the measurement. Now, say for example, you have these measurements here. I'm just going to grab some dimensions so I know what to do. So we have 5 feet there. Let's continue. Another 5 there and another there. So let me just change something, DIM, because my drawing is extremely small here. So things are a bit large. Modify that. Come on, modify. So I can change the text height. Change that to 1. Alright, set current and close that. Alright, let me go take out that as well. So let me just add my dimensions so I can explain things a bit better. Alright. Oh, and something that you should note again. When you hear them talking about scale and all that stuff, it does not mean you're going to scale up your drawing or you're going to scale it down. No, 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 that's not what you're doing. They're referring to when you're laying out your drawing in layout space. So I'm not going to touch on that now, but let's focus on the elevation. So if you're going to be doing an elevation or a front elevation of this here, all you're going to be doing is picking up everywhere there's a corner as well. And you hear me talk about corner because corners are what you'll see as the visible edges of the building. So for example, this corner here, this corner here, this corner, this corner. If there was a window inside here as well, the ends of those windows or the doors or the openings will also be a corner. Alright, now you'll be working with the dimensions that are given. Typically they don't tell you exactly where the windows and doors are in the exam. You just use your judgment and probably place them in the middle of the wall or wherever. Alright, in the vicinity of where it should be. Now, how do you produce your elevation? You're going to do something as simple as this. You're going to start by drawing a vertical line. Alright, and you see this vertical line here is where everything is going to start. All you're going to be doing is offsetting to the right or to the left depending on which side you start from. So for example, this line here is representing this corner here. Alright, the next visible edge that we have, or corner that we're seeing, is right here. And this corner here is 5 feet away from this corner. So it means that you're going to be offsetting this line here to the right by this number here. So you'll offset it by 1, I don't even know what that number is, 115.47. So you'll simply offset the line 115.47. And then you'll have that visible edge. Now that will be that visible edge here. Let me turn on my thickening line so you can see a bit better. Now the next visible edge is right here. If you can see my cursor, this is the next visible edge. So it means that we need to find out how far is this away from here. Remember what I said, everything is located somewhere in relation to something else. This corner here is 9 feet away from this corner. Again, this corner here is 9 feet away from this corner. So if we're going to be drawing this corner here on our elevation, we're going to enter 244.29. So we go offset 244.29. Alright, and you offset it to the right. Alright, then now there's another visible edge, which is this edge here. How far is this away from here? it is actually whatever this number here is. Oh, you see these numbers are actually inches. So this here is 319.76. So you go ahead and you offset 319.76, and then you will offset the line. So just like that, and elevations are pretty easy when it's like this. Just like that, you have all the corners or the visible edges. The only thing that you need to represent now is what? The floor level. Alright, and remember, you clean up as you go along. You'll have the roof level where the fascia is, and they'll tell you how far away from the ground or the floor the roof is located. Alright, so say for example that is it now, right now. Alright, so all you'll do at this point here is to do some cleaning up. You clean up your drawing. What are you cleaning up? All these extra lines that you have running up below here, you could get rid of them if you like. Here, alright, you could do the same thing up top here, because you know these lower lines aren't going to be passing through the roof. Alright, so we have these spot here. So the only thing that you need to do, if there was a window or a door somewhere here, you'll simply just pull it from design center and put it there. Alright, you take it from design center and you put it there. So if there was a window somewhere here, you simply place your window there. If there was a door somewhere here, you simply place your door there, whether you're pulling it from design center or wherever you're pulling it from. Alright, you'll put your door there. Alright, now when it comes on to the roof, remember, I want you to remember this. All these lines are visible edges. Visible edge, and I'm going to say it is change in depth. When I say change in depth, I mean that they're at different distance apart. So you might be in front of me, or you might be behind me. That's what I'm actually saying. So what this is saying that it's either this here is behind this here. This is a bit further back than this, or this is a bit further forward than this. Now, how would you know? You'll utilize your floor plan to know that, okay, this portion here is the part that sticks out. Alright, now when it comes on to the roof, especially if it's a hip roof, what I recommend you doing is that you're going to be offsetting to the right, for example, because here we'll have, and you'll see it on the roof here. And let me go over there with this. Let me go over there. Roof. So you can see a bit better. Alright, so here we are. You can see that the roof is some distance away. And sorry, I got distracted a while ago. From here to here, the roof is hanging off the building by a certain amount. In the exam, they'll tell you this measurement. Here is how you represent it without having to project lines down from a roof plan. Because remember, you don't need to draw the floor plan and all that stuff. All you'll need to do is offset, what am I offsetting? The roof overhang. For example, if it's a, whatever they tell you, I'm offsetting here to the right, on this side here to the left. Now this part that sticks out, there's a portion that hangs off to the right and off to the left. Alright, now it looks a bit crowded now, but once you've started to clean things up, things will look a lot better. Alright, now for example, the fascia. I'm assuming that everyone would know what the fascia is. The fascia is that board that runs around the edge of the roof, going around it. That piece of flat board there, that the roof, that show. How would I describe this? Everybody know what a fascia is, right? Everybody know what a fascia is, right? Fascia board. Somebody say yes. Mechanical persons just have to wait your turn, and nobody is cooked. Mechanical persons wait your turn and will be there. In the meantime, practice some past paper. Alright, you're not cooked. So here's what we're going to be doing for the roof or the fascia. In most cases, they'll tell you the fascia size. Whether it might be 150, millimeters, 200 millimeters, whatever it is. All right, they'll tell you what that is. Now, this will be, say this is your fascia. It means that this portion here, that's where that part of the roof will stop. And remember, you're cleaning up as you're going along. So for example, this is that portion of the roof. On this side, it's the same treatment, meaning that you're going to be filleting here and here. All right, mechanical persons, just wait your turn. All right, I'll be there shortly. So as you can see, we have the two portions that hangs over the building. It's the same thing on the middle portion here. All you're going to be doing is that instead of trimming and filleting and all that stuff, all you're doing is extending the lines that you have offsetted. Alright, but your technique might be a bit different, where you probably drew a line, or it doesn't really matter what technique you use. Just be efficient, as efficient as possible in whatever you're doing. Alright, so as you can see, we have our fascia, and I have the edges, or the visible edge of the portions of the roof. Alright, now if you have seen my video on how to do roof elevation, then you pretty much know what is going to happen here. I'm going to be drawing lines at angle of 35 degree, but this 35 degree is not set in stone, because this could be 45 degree, it could be 15 degree, depending on whatever they tell you, if they tell you something like this. Because they might not tell you the angle, but they might tell you what the height of the roof is. Alright, in this case, let me just draw a line that is 30 degree. Let's use dynamic tracking, ensure that 30 is selected, or you can manually enter the angle, it doesn't really matter. Alright, so again, once things are symmetrical, you simply mirror to the other side. Alright, so for example here, you mirror here. Let me just double check. Like that. And then now you simply connect the apex. And when I say connect the apex, I'm talking the peak of the roof. Whenever you hear me say apex, I'm talking about the peak of the roof. Now for example, this small portion of the roof here. Alright, now this is why it's important that we have this at the angle. And you'll draw an angle here. Again, here is perfectly symmetrical to here. So all you simply do is mirror to the other side. In some cases, you might accidentally mirror to the wrong point. Don't be afraid. No reason to erase what you have. Just simply modify, and I always encourage you to do this. You don't ever start over. All you do is modify. So you modify your drawing and you continue. Don't be erasing 30 minutes of work and starting all over. Alright, there is no need for that. Alright, so this is what a simple elevation, or the elevation of this roof here, will look like, as well as the building here. That is it. That is the elevation, and it will be the same treatment if you're doing a side view and all that stuff. Simply offset those lines going to the right or to the left, then you add your roof. For your section may vary. Section may vary, and remember, it is always where they cut the building. So for example, if I were to say I'm going to be cutting this building, I'm going to be cutting this building across the roof right here, right? It means that I would have passed through this room here and probably here as well. So what would I see in the background? What will I be able to see? I'll be able to see all of what is going on in this room, all of what is going on in this room here over here. Alright, now let me get my computer charger before this computer dies. Give me a sec. So we're almost there. Mechanical person, be a bit more patient. No way it get whether the paper get leaks or not, it's either you can or you can't. A leak paper will not, well, I guess it could benefit you because you could get to practice it before, but it leaking will not help a person that is already should I you guys are using the term cooked. somebody has it already, believe it or not. That's plugged in now. All right, so let's see. With the sectional view. All right, so say we're cutting the building here, and again, if they're asking you to do a sectional view, you're not required to draw the floor plan. All right, so all you'll be doing is looking at your floor plan as it is like this, and simply be drawing the line. Now, in your floor plan that is going to be on your in the thing that they're going to give you tomorrow, it's going to be single line. You're not going to be seeing double lines. All right. All you'll have to do is simply offset the thickness of the wall based on the specification that is in or on the sheet. All right. So they say the wall is 150 or 100 or whatever. If you're doing a sectional view, once you have drawn the first vertical line, for example, I would be drawing a line now. The line that I'm drawing, and let me just explode all of this here so you can see. So the first line that I drew is actually representing that line, because what? The sectional view cut through this line here, cut through the entire thing here, but it passed through this wall here. Now wall is not a single line, it is two lines, so we have to offset whatever the thickness of the wall is, whether it's 100, whether it's 50, whatever it is, what if it's 150, it doesn't really matter. All right, just offset the lines to represent the wall. Now again, the next part would be this wall, because this is where the section line passed through next, right here, pass through that wall. All right, but how far is this wall here away from here? Now you'll see this from the dimensions. You'll see this in the dimensions, and all you'll do is simply offset the lines over even further. All right. By the time you're finished, you'll have. By the time you have done all that, you'll have lines representing the three walls that this section line passed through, and then everything from here is the same elevation. All right, where you simply draw the floor level, you'll draw the roof level. However, the only difference is that for the elevation, you'll be seeing the outside of the building, and the outside of the building only, such as the roof, the walls, the fancy windows from the outside. But when you're doing the sectional view now, you're seeing inside the building. You are seeing inside the building. So now you'll be seeing inside the building. So if there is a kitchen in the back here, you'll see the kitchen. If there is a bed around the back here, you'll probably see that. If there is a window there, you'll see it. Things like that. The only way you would not see if there is a window or a bed inside of this room here is if your cutting plane was where? If your cutting plane was here. If your cutting plane is here, it means that when you look, or you're looking up towards this area here is an open area, so you would be able to see whatever is around here. But when you look on this side here, all your eyes will be greeted by is a wall. So the only thing you'll see is a wall. If there's a door in this wall here, you'll see it in the background, so you'll have to represent that. But if it's just a blank wall, then there will be nothing. It will just be a wall. So that's the only thing you need to know there when it comes down to sectional view there. All right. Same exact thing, same exact way as how you'll do an elevation drawing. The only thing is that you're now seeing inside the building. But it's the same way you do the windows, same way you do the doors, same way you do the roof. Nothing changed. You're just going to be adding a bit more information or details to the drawing. Alright? Because down below the wall here, you're going to have the foundation footing detail. Up top here where you're going to have the roof, you're going to have the eave detail. Probably in the middle somewhere you'll have the ridge detail. Things like that. And then you'll have probably windows in the back. Alright, if you can visualize what is going on here. Let me show you something. So this here would be say your foundation pad. Alright, so this would be I hope this look familiar. Seems familiar to you. I'm sketching this out for you. That's basically what things will look like. Alright? Then you're going to have the roof up top. You're going to have the roof up top. What will the roof look like? Its roof is going to look like somewhat like a triangle. Now, inside of this triangle, you're going to have what? You're going to have the rafters. The rafters are coming down like that. Again, this is an overly simplified elevation, but it's just to explain how you position the wall, and that's where persons tend to fall down and somewhat in the roof. Alright? But it's nothing too complex. Again, building persons, please read the information or read the question. This is how you're going to know what to do. Alright? That's how you're going to know what to do. That's how you're going to know what to do. So the first thing you're going to do is, alright, look at the floor plan. And you can say, alright, it doesn't look bad. Let's see what we have to do. Then you read the instruction and you found out, alright, they say do an elevation. Or they might say complete the floor plan. If they say complete the floor plan, then you know you're good. You just reproduce the floor plan, complete it, ensure that the walls have thickness. Put the furnitures, only the furnitures that they ask you for. Alright, don't waste your time doing things that they don't ask you for. Alright? Because alright, so as you can see here, we managed to do a quick layout. We touch on the multi-line tool, how it operates. We did a quick foundation plan. We did a quick roof plan. We did a quick elevation, and we did a quick sectional view in explaining what is going on here. And remember, using AutoCAD things can take a bit more time, especially when it comes down to sketching things. Alright, and as you can see, we're already there. We're just like probably an hour in. Rest of what? Wait, sir, how long from the floor? Alright, now in the exam they'll tell you how far the bottom of how far the foundation is going down. They'll tell you these things. Everything will be in the on the paper. So they'll tell you the depth of the foundation if it's a case like that. They'll tell you how fat these pads should be if they're asking you for something like that. They'll tell you everything. They'll tell you the size of what everything should be. They'll tell you the thickness of the wall. They'll tell you the height of the roof. They'll tell you the fascia. They'll tell you the windows. They'll tell you everything. Alright? They'll tell you everything. All you're doing is just drawing what they give to you. So if they have to draw a window, you just draw some rectangle according to the measurements that is given. You just draw that. Alright? So here we go. Site plan. Site plan. Now they will give you I think I have a video on the channel on that. Now they might give you, now typically, you know, a site plan will show the relationship of the relationship between the different components on the site. When I say site, I'm meaning the property. Think about the site being your house, right? The fence around your house is the boundary. Alright? And on this site, you're going to see where, for example, the house is. You're going to see where the driveway is. So it's going to show you where the driveway is. It's going to show you where maybe you have a gazebo on the property, a pool. It's going to show you where it is. It's going to show you how far it is away from the building. It's going to show you the guardhouse. It's going to show you where the gate is. If you have a mango tree around the back in a corner that you raid every evening, it's going to show you those stuff. All of that stuff you'll find on your site plan. Also, in some cases, you might find drainage. Alright, when it comes on to sketches, I don't know where we got this from, doing sketches in AutoCAD, but sketches are typically freehand and it is done on paper. When it comes on to sketching, it can be time consuming to do it in AutoCAD, especially given exam condition and them giving you limited amount of time. As you know, typically they say what, 30 minutes for the sketch and design portion. So you know that can take time. So if you're not pretty quick, you can lose a bunch of time there. But it can be done. It can be done in terms of like the sketching in AutoCAD. Because what is going to happen is that you're going to want to make things as accurate as possible in AutoCAD when it don't need to be accurate in terms of like measurement because it's a sketch. All right. So that's where things. That's the drawback when it comes on to sketching in AutoCAD. Why person saying paper leak? If you got the paper, let me see it. I guess I shouldn't be seeing it because I'm marking exam this year. So um, yeah. So um, as I said, building person, your sketch and design could take so many forms. As you can see, last year they told persons to. Last year they told person to do. Persons were doing. I think they said load bearing and non-load bearing walls. I think sash window. Um, previous year I see they wanted orthographic views of the different types of windows, or I think they list the types of windows that they wanted. They asked for us to do foundation, putting detail. There are so many things. It's hard you know it. That's why I say, if the paper leaked and all that stuff, it wouldn't even matter. It's either you do know or you don't know. All right? Because if you can't, you just can't. I mean, for some person, it could work out in their benefit because at least they could, all right, this is how I'm going to approach it. Um, but in most cases, no, it won't make a difference whether it's leaked tomorrow morning or not. Won't make a difference. At least not in my views, anyways. Because I say it's either you can or you can't. So let me just quickly show you how to draw the angled line in AutoCAD when it comes on to if you're going to be doing like a boundary or so. Now, this is the simplified version because in reality, say for example, you mastered AutoCAD and you're doing you're a draftsman for say an architect, an engineer, or a surveyor, right? You'll be using different values to to get the bearings or the boundaries of properties. For CXC, they'll give you the drawing. So say for example you're drawing a line and you'll see it coming across like this and it might have a specific measurement. It's flat. It is whatever measurement it is. But then you notice that they say that there is an angle or the property moves up at an angle of say um, 26 degree. Alright. Now you could find it using your dynamic tracking thing and cooking your way around. But the moment you click, something is going to be off. So I always encourage person to manually enter these angles. Now, typically, and all you need to do is, and persons have different strategies for entering the angle. This is how I was taught um, to enter the angles. I was told hold on the shift key and select the greater than symbol. Once I select the greater than symbol, I enter the angle that I want. In this case, 26 degree, and press enter. Alright. What that does, it locks your cursor onto that axis of the angle that you entered. So it doesn't matter where you move your cursor, it's going to stick to that angle. And the only thing that is left for you to enter next is to enter the distance of the line. Alright? So for example, if they say it's say 100, 1000, whatever, you enter the angle, then now you draw the other line. Now you might see that it might comes this way by a certain amount. How are you going to enter this angle? Now, typically, AutoCAD records angle in a anti-clockwise direction or clockwise direction, depending on how you want to think about it. Because if you want to, and this is just a workaround that I've came up with, or I found, is that you might not want to calculate what's the angle from here, because this might be 90, right? This is 45. All right, so it starts here. This is 0, 45, 78, whatever, whatever, whatever. But the angle that they might give you would be from here to here, and you might not know the angle from here to here, the angle between there. Alright? So what I typically do is that I would simply, because if you think about all lines, all lines, so from here to here is 180, right? And it comes around. So from here to here is 180, and then there's another 180 coming around underneath here. Now, how I was taught when I was in school, because I didn't really do TD like that. I just got up one day and like, I'm going to do TD. And I did it in a few months. I think I started the classes in about December, and I did the exam in June. Alright? So, this is how typically things are represented. So, you have the angle here, alright, and you enter the angle. So, it's greater than symbol, you enter the angle, press enter, or you can press the tab key, then you enter the length of the line. You will determine it. So, for example, if they say between here and here is a certain amount, you enter that angle, alright? Whether you want to calculate it manually, we had to calculate it when I was in school, but you don't necessarily have to. Because if I'm in a crunch and I don't want to calculate, or I don't have a calculator, whatever it may be, even though there's a calculator in AutoCAD, I just simply draw the line up close to where it should be, and then I'll check wherever the measurement is. So say for example, when I check the measurement, and I'm just telling you different things that you could try here. You could try, or you can utilize if you're in a pinch. So say for example, this angle should be 75, right? The angle between here and here should be 75, but if you see, it is currently 83. So all I'll do is continue to rotate this line. So I'll probably rotate this line by the difference to get it to the 75. So I'll rotate it. How am I going to rotate it? I'll simply enter the angle. So I'll simply enter the angle. So if it is at 83 and I need it to be at 75, it means that how much is that? 8, 75, 76, 8. So I'll simply add 8 to my rotation angle, and I'll get the measurement. Now, in some cases, so let me just enter 8 and see what happens here. Alright, so when I enter the 8, as you can see, it adjusted itself. So now it's at the angle that it's supposed to be. Alright, and then now you'll finish the process off by continuing based on the angles that they gave you for the property boundary. Alright, once it is there, you simply grab onto your building that you have, and in cases like this, you'll have to draw the floor plan and you place it on the property. Alright, based on the specification that they give you, because they'll tell you where the building should be on the property. Alright, you just have to read the instruction and you find out where you're placing your building. Alright, where you're placing your building. So that is how you pretty much would do that. You know to do the floor plan already, drawing the angles for the boundary, and you should be good. Should be good. Should be good. This side plan, I think. Let's do. So this would be your typical side plan. Again, something you should always remember to put your title for everything and the scale. There is mark allotted to that. Alright? Or I always do it, I will simply say you can use a text tool. Now some person will go fancy and they'll use the title from tool palette, but you don't need to go all the way out, all out like that. Just simply use your text tool. If you want to use multi-line tool, and you simply enter what it is. So for example, you would just simply type site plan or whatever it is. So say for example, this is our site plan. I write site plan. Is it typing? Is it typing? You simply type site plan at the bottom here, and then you'll write the scale underneath it. Say if they say the scale they should draw is 1 in 50, 1 in 100, you just simply type that. Alright, type it below it. Just type the word. Type the word, you can't go wrong. Alright, when it comes down to laying out your drawing, again, I've noticed that teachers might teach some students to draw a box around the drawing like this. Some teachers might do that, and some might tell you to to scale the drawing. So they might tell you to scale the drawing or something and make it smaller or bigger or whatever. Don't do that, right? Now, because when you do things like that, if you need to go back and make adjustment, it means that your drawing has been messed up. Because remember, you changed the measurement of it when you scale it down, because you have turned something that was 50 into 20. It is no longer 50. So how are you going to modify things? Now, there's a reason why AutoCAD is so expensive, I mean, almost 2K a year, 2,000 US dollar that is, per year. It means that they have thought about everything. When you're laying out your drawing to the scale and everything for printing, for the PDF, say school can print it and all that stuff, come down to here where you see layout. Now, typically, it will look like this on your computer. You'll see layout 1 and layout 2. Alright? Where you'll have layout. Now, I have my title block all set up here. I had this a long time now that I created, this old template here. If you want to access title blocks that are in your AutoCAD, you see this plus button here, simply right click on it and select from template. Once you click on from template, you're going to be greeted by this window that should pop up in a bit. Alright? And you can choose from a variety of different title blocks to use. Bear in mind that you don't really need a title block. For all CSEC here, it could be a blank paper with your name on it. Alright? Just ensure that you have the title below the drawing. So that is a side plan, that is a roof plan, that is an elevation, that is a floor plan. Whatever you're drawing. Alright? This is just being too flamboyant with your laying out here. Alright? But it's not really necessary for you to go all out like this. Now, once you have all of these layout down at the bottom, whichever one you choose. Now, if you have selected, say, one that is, what am I going to say? One that is, say, one from sheet set, and you select one that says architectural metric, right? Or architectural whatever. Now, these title blocks that are here, believe it or not, CSEC wants you to print your exam on 11 by 17. Now, you see, these papers aren't 11 by 17, these ones that you see here. These aren't 11 by 17. These are actually 24 by 36 inches. Alright? So, when you lay out your drawing on this, even if you scale it, things might be a bit off once it is printed. Because think about you printing a 24 by 36 paper on 11 by 17. The aspect is going to be slightly off, and if the aspect is slightly off when it's printed, if I were to check the scale on the drawing in comparison to what you wrote, things are going to be a bit different. Because what the scale is actually saying that if it's a scale of, say, 1 in 50, what does this 1 in 50 mean? It just means that for every 1 millimeter on the paper that you're seeing here, in real life, that measurement will be 50 millimeters. So if I measure from here to here and I get 5, in reality, in the real world, the measurement would be 5 times 50. Alright? Because since 1 millimeter is equal to 50 millimeters in real life. Alright? Now, back to laying out your drawing. So typically, this is what your layout is going to look like. You won't be able to have your image here. Now, in order for you to have your image here, you need to do one thing. And it is my favorite friend. I call it V-port. Sounds a bit weird, but it's called V-port. V-ports. So once you type V-ports and click on V-port, you're going to be greeted by this window here. You're going to see single, 2 vertical, 2 horizontal. If you click on it, you'll see some stuff happening. Alright? Now, I always select single, and I call these viewing portal. Why? Because it's a portal that allows me to see within my model space from the paper space here. So what I'll do, once I've selected viewport, you realize that it has activated my cursor, similar to when you're trying to draw something. So all you need to do is draw a rectangle within the boundaries here like this. Once you have done so, you're going to see your pictures or your drawing. All you need to do is double tap inside here, zoom in around the drawing that you want. Alright. Now in some cases you'll have to set the scale. So if you're going to set it to 1 in 50, no, I mean mine is going to be off now because things are a bit whacked. Most of this is sketched. But you'll simply go here and select this drop down menu and select whether it might be 1 in 10, 1 in 20, 1 in 30, 1 in 50. AutoCAD will automatically adjust your drawing to where it should be. Alright, it will automatically adjust it to that 1 in 50. So when that somebody comes and measure it, they'll be able to accurately determine what the measurement will be in real life, even if there is no measurement on here. Alright, once you have positioned your drawing, simply double tap on the outside and your drawing is all good and Gucci. Everything will be nice, and all you have to do is create your PDF. Now I know for some schools they create the PDF for you if you didn't, because CXC wants the hard copy. Yes, the drawing files are uploaded to the portal as well, but the hard copies are what us as markers are going to be looking at to mark your grade. It has to be something serious for us to be looking at your soft copy. Alright, so this is what your layout will look like. Please remember to write your name and all that stuff. Create your PDF, save it on the flash drive or on the computer, wherever you're doing it. Your school will do the rest. The school will print it for the CXC and all that stuff. Alright, so that is you there. You lost? I was touching on how to lay out your drawing. I'm assuming you don't know how to lay out your drawing. Well, you don't need to worry about that. Because if things are that bad, your school will lay out the drawing for you, or your teacher, or somebody there, so that they can print the drawing to send to CXC for you. Alright, to ensure that you pass. Alright, so I'm just going to run through layout one more time. How to lay out a drawing. But your focus right now should be on how to do your drawing. Alright, because that's where you're going to be getting the bulk of the mark. So where you have layout 1, layout 2, and layout 3, or the one at the bottom, just right click on the plus button, select from template, and from there you could go to sheet set. Please bear in mind that there's so many things that you could do, because you can set up the paper size and all that stuff. This is just a quick run on what to do. Once you click on sheet set, click on any one of these here. The option is yours. Mechanical person, you can choose manufacturing. Building person, you could choose civil or architectural. I prefer, or I would say, choose metric, or one that says metric, and then you just click on OK, and you'll see this window pop up. Just click on whatever is inside there. Whatever is inside there, just click on that. Okay, yes, the process is long. Sorry, but this is just something that you have to just know. Alright, but as I said, if this is not done, then your teacher would sort this out for you to ensure that the work can be printed and sent off to CXC in the afternoon. Once you get to this point, type Vport. This will allow you to turn this change this from a blank paper to something that will allow you to see into AutoCAD, or the model space, where you can simply zoom in on your drawing or set the scale, and then you double tap on the outside and you'll be good. But don't worry about this too much. Focus on how to do the drawing. Alright, focus on that. Sir, section B, prediction. What, for building? I have no idea what's coming on that. No idea. So if you're a TD student and you do building technology, you should be fine. You should be fine. Sorry. No, it won't be wrong if a mechanical person chooses an architectural sheet. It won't make a difference, alright? Because you could use a simple layout that is down in AutoCAD as well now. both mechanical and building person. You see the one that says little one, you can do it there, you know. All you need to do is change the paper size, you know. How do you change the paper size? All you need to do is you could right click on it, so you right click on it and select page setup manager, and you change the paper size to 11 by 17. That's all. Once you change the paper size to 11 by 17, click on set current, you realize that the page has adjusted. And all you do is that you see this little window that is here, you simply open it up. And remember to add your name as well. You can add your name here again. Same exact principle as how you'll add your name in AutoCAD. You just use the text tool here, and then you type your name wherever you want to type it. So you type your name and candidate number. If things are too big again, you can always change the font size. Font size is changed just like in Microsoft Word. You'll go over here, click on this, and then change that from 50 if it has 50. Maybe you can put it at a smaller number. You could fill things out if you want as well. And then you set that up. But that's nothing major. Alright, so I'm moving from there now. Where are my mechanical persons? No, you can do it after. You can after you close the viewport, you can write your name. After you close the viewport, you can write your name. Oh, how to set up your units? Now, if you're given extra time to set up your units, alright, so here's how you set up your units, alright? Now, mechanical building persons, your unit is going to be set up the same exact way. So here's how you would set up yours. Now, typically, maybe you would have selected one of these here that says um, AutoCAD ISO. I'm trying to find one. AutoCAD ISO. AutoCAD ISO. Alright, AutoCAD ISO. Alright, so say this is it, right? AutoCAD ISO. Right? How are you going to set up your units? You're simply going to be doing something like this. Just type, no, you can access it from up here, but I say units. So I'll type UN and press enter, or just U, and then this window pops up. So units, enter, and you set up your units here. Now, by default, if you select AutoCAD ISO, it's going to automatically going to be on millimeters. So you'll leave that there. Precision, you could always, since it's millimeters, just leave that, put that at 0. Where it says type decimal, you can leave that on decimal there. Alright, no need to put it on architectural, no need to put it on scientific, none of that. Just keep it on decimal, millimeters, precision 0, and then select OK. Alright, and that will be your unit. That's how you set up your units. Let me see what you have to say there. There is nothing much to that. Alright, as long as the curve reach the ground, so I have good SPA, so I'll do good. No, if you have a good SPA, it means that you put in the work, alright? And if you put in the work, it means that your knowledge base is there. So you'll do perfectly fine. Grade 1 for you. As long as you did your SBA and you did it good, it means that you will have gone through the process and you understand what is going on, and you'll be fine. Mechanical person, building person, same thing. You can see the screen. Any other question before we go, if we need to go? Yes, the SBA is worth 40% of the final score. Imagine going into exam with 40%. Even if you got 38, it means that you're on your way already. And if we're going to assume that the pass mark will be 50, it means that you only need to score 10 marks to get a passing grade. But you're not just getting a pass, you're looking for grade 1s or 2 or even distinctions. So you'll be fine. Alright, so 40% of the final score. All right, good night, good night, good night. All right, ensure that you rest up for tomorrow. What would I touch on for mechanical persons? Nothing much, just as I said before, once you get into the exam, just start draw. Just read what they have asked you to do. If they say do a plan view, ensure that all in detail are shown, hidden features, all that stuff, just draw. Because everything that you're going to be drawing is what you'll have to put together afterwards anyways. So if they say do a plan view and an end view, it means that the only thing that you should be concerning yourself or anything that has to do with plan on the part sheet, you drawing those first. When it comes on to the sectional view or the end view, you start drawing those parts afterwards. And after you start to put them together. And anything that cover each other or you realize that it is above or below, if you know that it's going to be there, you simply just change that portion to hidden detail line because, you know, if I have one on top of the other, um, well, let's use a bed, right? We have the bed, right? And we have a mattress. Mattress, that's what they call it. I put the mattress on the bed, right? We know that now the mattress is covering the bed, at least the frame that is. We know that there are boards running across it, but we're not able to see those. So all we'll simply do is just change, if we're going to be representing those in our drawing, we simply change those lines that are representing the boards underneath the bed as broken line or in detail line, and that's how we'll represent that. All right, that's just a quick example. Sectional view, think about it like a cake. Imagine you going to buy a cake, say a red velvet cake, not well, a regular cake, and you ask for chocolate cake. But there's no way for you to tell that it's a chocolate cake. Alright? Why? Because it's covered in icing and all that stuff. Alright? Unless you cut the cake. But what if you ask for vanilla cake, but when you bought it, it was covered with icing, you brought it home, and when you cut it, you realize that half of it is chocolate, half of it is vanilla. You weren't able to tell that when it was one solid cake, but when you cut it in half or cut a wedge out of it, then you will be able to see the inside of the cake. And that is, in essence, what sectional drawings are. Alright. As I said before, for sketch and design mechanical drawing, um, they'll probably give you an orthographic to do. They'll give you the orthographic and say draw a sectional, not just a sectional, draw a isometric drawing from it or an oblique drawing. Now here is how you'll typically, if you're using a more modern AutoCAD, then you're going to have this feature here, the ISO mode. Alright, I know persons use dynamic tracking for this. I don't recommend it. Persons use this, but remember what I say. Sometimes you might be drawing the line, right? And you see the green line, but when you click, it didn't snap to that 30 degrees. So when you start drawing things around, you realize that after a while, it's as if things aren't falling where they're supposed to be. Why? Because at some point during the process, you didn't draw one of the line at 30 degree or on the 30 degree axis that's supposed to be there. That's why I encourage person, if you're doing it, two things that you need to do. Ensure that ortho mode is turned on and ensure ISO plane is turned on. And you toggle between all the different planes, the ISO left, ISO top, and ISO right. Alright? So for example, if you're, and I'm just going to use a simple example, drawing a rectangle or a square, whatever it is. All right, drawing a rectangle or a square. All right, as you can see, I was currently on ISO um, left. All right, as you can see, my cursor can only be moving to the left from right to left. Now, if I were to select ISO right, and you can use the F5 key to toggle between them if you want. ISO right, it allows my cursor to now move from left to right. So ISO left, my cursor move from right to left. ISO right, my cursor move from left to right. ISO left, again, your cursor move from right to left. ISO right, your cursor move from left to right. So in this case now, instead of moving from left to right, I won't be able to do that. Because why? I have ortho turned on. And ortho is restricting my cursor to only draw on the vertical and horizontal axis of whatever I'm drawing on. So I'll only be able to draw a line running this way and up. Alright, so for example here now, I can draw a line up and across like that. Alright, now this is how it can be done, or it should be done pretty easily. Alright, now when it comes on to like top portion, again you could use ISO left and right to draw it as well, but believe it or not, there's a function known as um, ISO top that allows you to draw an ISO top, if you want to call it that. Alright, so you'll be able to draw top portion like that. Alright, I mean this is a sketch and I'm not trying to make it accurate, but this is just to explain what is going on there. Alright, explain what is going on with the ISO. If you're going to be drawing circle again, circles, you don't use the circle command for isometric drawing. You're going to be using the ellipse tool. Now I don't know what happened with AutoCAD and what they did wrong, and it has been like this, where to draw an elliptical circle in ISO mode, you have to select the ellipse tool. You have to come back and select the ellipse tool again, whichever way you want to select it. It's the second selection you're able to draw the isometric circle. But first you have to select iso circle. Then you'll be able to draw the iso circle. Alright? So you have to go to ellipse, activate the command, activate it again, then select iso circle, then you'll be able to draw your isometric circle. Again, ensuring that your base point is where it's supposed to be and all that stuff. So that's that there. Again, gents, ladies, if you're here, I suggest you guys try to get some rest. Alright? You want to practice in the morning when you get to school, you can exercise those mouse fingers of yours for when the exam start. Purlin and lot. Now, the measurement for the purlin and lot, if something like that is going to be given, they will tell you. It is not what you want, but the only time you use your measurement for anything in the exam is if it is not specified. But in most cases, they'll specify whatever what should be. So if they say fascia is 50 millimeter by 150, or they say the purlin is 50 millimeter by 75 millimeters, whatever it is, they'll tell you. Free AutoCAD, once you're a student, you can get AutoCAD for free. Alright, you just need a student ID. If you don't have a student ID, you can use your report card. If you don't have a report card, you can get a letter from the school and you upload it to the website. Alright, students get to use the program for free. Alright, you don't need to pay that $2,000 per year. Alright, student gets to use it for free. All the papers are typically easy. The exams aren't hard. The older papers are more complicated. But then again, back in the day, the exam was like 3 hours. It's less time now, so it's not as complicated as it used to be. Well, if you get a floor plan, that would be good. If you get a section, if you get a floor plan, it's even better for you because you can hit the ground running. If you get elevations or even section, then it's pretty much the same thing. Just use my technique and you'll be fine. Again, if they ask you to do a sectional drawing, don't draw the floor plan. If they ask you to do an elevation, don't draw the floor plan. The only reason why you should be drawing a floor plan is if they ask you to complete the floor plan, or they say draw a roof plan, or they say do a foundation plan. Or if you have to do a site plan, then you'll have to draw the floor plan. But once it's an elevation, sectional view, those stuff, don't draw the floor plan. All right, just do the offsetting thing. Internal concrete. I'm not sure what you're talking about. You meaning the walls? If they'll tell you the thickness of the wall, tell you the thickness of the wall. So they'll tell you that internal walls are 100 millimeters thick and external walls are 150 millimeters thick. Or they might say that external wall 150, internal wall 150, or external wall 100, internal wall 100. They'll tell you what each one of them is. What does what mean? Building technology? I don't. When is the exam for building technology? Is it next week? If you're going to get a staircase, the staircase would more likely come in the sketch and design portion if they bring that. All right, they might give you a orthographic and say do an isometric of it or something. But I don't know. There's so many things that could come in the sketch and design portion. Um, the CXC does not stipulate which CAD-based program you can use. They don't. They don't. They don't. They don't. Because some school uses Google SketchUp. Some school are using AutoCAD architecture. Um, some school are using regular AutoCAD. So they did not specify. They just said a CAD-based program or software. All right. It's just that where you're from, they probably just love AutoCAD because they think it's the way of the future. Not really, because I don't use AutoCAD to draw it professionally. I use other software that are more um, intuitive and more smart. There's no way you can be doing TD and you don't know how to draw. Alright? So don't say that. Alright? Believe in yourself, man. Believe in yourself. And how we get the numbers. ArchiCAD is. ArchiCAD is similar to Google SketchUp in its behavior, in the function. Um, AutoCAD also has similar function. Now you might be wondering why the program is so heavy and large and expensive. Everything that Google SketchUp can do, everything that AutoCAD can do as well, believe it or not, AutoCAD can do it as well. It's just that it's more, how should I say it? I don't know. It's more, it's more archaic if you want to think about it like that, but a powerful software. And this is where the entry comes in. It will be like IT. Why do they teach you guys Dev Pascal when it's a dead programming language? Why don't they just teach you Python or one of the other programming language? Because this is the entry. This is the fundamentals. All right. Once you can learn AutoCAD, you can do anything or learn on any other program. Cross sections are sectional drawings. Think about it like you cutting a cake. All right. What would you see? All right. All right. So everybody, go and get some rest. All right. It is now. Well, it's almost 1 o'clock where I am at. So it's late for you guys. You guys need to get your rest. Can't be going into exam all tired. All right. CXE marks exam based on a curve. Um, it's possible that you can even get 20% and still pass. However, that's highly unlikely when you have students who are going to be doing extremely well and getting almost perfect score. So the bar is always high. Alright, so you can say do bare minimum. Yes, you might have a good SBA, but there are persons that have almost perfect SBAs and still failing exam. Alright, so it's not that's not the case. As long as you know to do oblique drawing, you should be fine. Let me do a quick demonstration on how to do oblique drawing. A quick demonstration before we go on how to do oblique drawing. So here is a simplified isometric. I mean, this is just a sketch, but oblique drawings are done in a similar fashion. However, the angles at which you're drawing, there is no iso mode for that or oblique mode for that. The first thing you do, and I'm using a rectangle, is draw the face of the object. The face of the object is always flat to the picture plane, flat to your screen, flat to wherever. What makes it different now is that the receding axis, is done at an oblique angle. That's the reason why they call it oblique direction. Typically, I draw mine at 45 degree. That's my oblique angle that I'll use. 45 degree, but bear in mind that this could also be 30 degrees, whatever. All right, oblique angle. All right, it's an oblique angle. All right, so say 45. All right, so the receding axis is at a 45-degree angle or at an oblique angle. So this is what your typical oblique drawing will look like. In relation to it, and you'll probably do this for your SD already. Now remember that there's two types of oblique drawing. There's cabinet and there's cavalier. Cavalier is when you draw the object based on the actual measurement. That's the cavalier. So if, say for example, the measurement from the back to the front is say 5, when you're drawing it as an oblique drawing, you'll draw the depth as 5. If it is a cabinet oblique drawing, it means that you're going to cut the measurement in half. And when I say cut the measurement, you're not going to be cutting the measurement for the ones that are on the picture plane, which is facing you. Only the receding axis are what you're going to be cutting in half. So if the receding axis was 10, when you're doing for cavalier drawing or cavalier oblique, then it's going to be 5. So even if this is 5, you're going to leave the face alone. Only the receding axis, the angled line, is what you're going to be changing the depth of. That's all. Alright, and ladies, if you're here, head out, head out, head out, head out. Alright, when it's time for the multiple choice, again, I'll post the multiple choice um, videos here, as well as there's going to be the usual treatment where I'm going to be attaching the PDF file to as a drive where you'll find all the answers where you can review them for the multiple choice. after tomorrow passes. All right. So that's how that is going to work. So you'll get the multiple choices as well um, to review. I'll have them posted. All right. So I'm calling it for tonight. See you all after the exam. Just leave a comment after the exam tomorrow. Let me know how you did. Let me know what came on the exam as well. I tend to not want to know what comes on the exam because when I do the paper for myself, I want it to be my first interaction with the paper for an authentic um, review, respond, and answering. So if I take an hour or 2 hours on it, or if I take almost 2 hours, it means that that paper was difficult. If I took anywhere between 45 and an hour, it means that it was moderate. If I took 30 minutes, then it means that the exam was easy. All right. Don't need to worry about cheating or drawing. If anything, your teacher will do that for you. All right. But you should know how to do that. How did you lay out your sheet, your drawing for your SBA? All right. So you have to ensure that um, you know that. You can do a quick video search on YouTube how to lay out your drawing, and you'll see many examples there as well. I deleted all my videos that looked at that. And oh, at the end of most of my videos, I show how to do that as well, even with the past papers and generating the PDF as well. All right, so somebody explaining it to you there. All right, so go to layout, right click, and pick layout to sheet. Pick a layout to sheet. All right, yeah. So valid detail. I doubt you're not going to get valid detail on the exam. Um, it's it's rich detail you'll get, eve detail, foundation footing detail. They're more they're more likely to ask you to do like a lintel and window or a door and lintel detail than to do a valley detail. Oh, and examples of valley, how to draw a valley detail is actually on the YouTube channel here. You just need to go find the channel and click on videos, and then just scroll down. You're going to see the big picture that says valley detail, ridge detail, foundation footing detail. All of them are described. Yeah, I doubt those aren't coming. I doubt it. I doubt those are coming. Who knows? Whoever write the paper knows what's coming. I'll find out what's probably find out. Yeah, somebody's going to send it somewhere. Or if you get the paper, you can email it to me and I'll look at the paper after the exam tomorrow. Wells for mechanical drawing? No, no, you don't know. Not for CXC technical drawing. No, you don't need to know that. No, you don't need to know that. They're not going to put that on it. Alright, so you're praying for floor plan. That will make things a lot easier for you. Alright, everybody go to bed now. I'm ending the stream. Alright. Have a good night's rest or morning rest for your exam.